All right, let's switch over to the presentation. And welcome to this session of Agile modeling for medical device development. So I've been involved in developing many different kinds of systems, from avionics systems to spacecraft to submarines to nuclear power plants. But I spent a fair chunk of my career designing and managing projects to build medical devices. Patient ventilators, ECG machines, MRI scanners, cardiac pacemakers, medical ventilators, and so on. And so I have a fair amount of experience developing that. And most of my experience throughout my career has been in real-time embedded safety-critical, high-reliability systems. So that's kind of my point of view, my perspective. So the first thing we want to talk about doing Agile and model-based systems development for medical devices is to understand that embedded systems are different than IT systems. If you get a Scrum book, it's typically 3 people in a garage working on a website. Those aren't the kind of systems I work on. The kind of systems I work on keep people alive. They're typically more complicated than just a web page. They require more people of different engineering disciplines like software, mechanical, electronics, hydraulics, control theoretic analysts, and so on. So embedded safety-critical systems are different than IT systems. They fit into a system where requirements are allocated to different engineering disciplines, as I mentioned, software, mechanical, electronics, hydraulics, pneumatics, optics, and so on. We often use specialized hardware, which is co-developed with the software. We have constraints on what we can do in terms of programming, both because we have safety and reliability needs, but also because we have regulatory constraints about how we can develop systems. And there are certain objectives and various standards that we have to meet in order to sell our devices in different locales. The testing environment is typically much more challenging than an IT system environment, because you don't have all the great tools on your small platforms. I was just in Germany last week talking with a number of people doing medical systems. And a lot of these systems are, small, 16-bit, small 32-bit applications running in a very constrained environment. They might have 30, kilobytes of memory in some cases, very small, maybe implantable devices. How do you test that? It's a much more challenging environment than just running tests on your large-scale system. Often the systems have to be highly predictable, and you have to be able to guarantee that in all cases the system does the right thing. And IT systems, not so much, right? Part of being predictable is the tight timeliness constraints. For example, on a cardiac pacemaker, if you pace the wrong time, you can kill the patient if you pace what's called the super vulnerable period. In life support devices, you have to respond within certain time frames or bad things happen. You see what's called the fault tolerance time in various conditions, and that can lead to injury or death. You often have, as I mentioned, very severe resource constraints. Memory is a common one. Other kinds of resources. Often our systems have to be safety critical and highly reliable. Subject to rigorous external regulation, and we often ship the system. It's very rare that we don't. That the device they get has the software embedded on it. It's not like it's separate.